We love sponsoring these type of events. We sponsor lots of events like this, and we love to support them, and we love to learn ideas. And certainly the last talks that we've heard are really inspiring around lab education. So we'll be taking lots of ideas from these and talking about those afterwards as well. So the goal of Learning Science, we're trying to support academic teams in what they want to do. So we're not trying to create resources that will just replace everything that you're doing. So all of the things that Linnea was just showing, amazing. We love that kind of innovation. And so our resources sit alongside, and in fact, we're working with Glasgow University and Linnea. Our resources sit alongside what departments are doing, using all sorts of a range of technologies. So hopefully, in the next 10 minutes or so, I can show you some of that stuff. I'm going to talk through some slides, and then at the end, my colleague Anthony is going to demonstrate some of the live content. But we're a partner in digital education. We're based in the UK, but we work right around the world. And we're a team of scientists and web developers and learning technologists and instructional designers who have come together to create with a real obsession around STEM technologies and teaching science. So at the moment, we've got resources being used throughout the world across bioscience, chemistry, and many others. And what's interesting is that, yes, of course, we're there to support, the practical science principally, but there are so many other areas which you get involved in. It's such a big topic that once you start to look slightly beyond, the nuts and bolts of labs and the experiments that are running and how students are prepared for them, etc. You're thinking about student engagement, trying to support their data analysis skills, improve student satisfaction, maximizing time in the lab so that students get the most of those really valuable experiences, providing feedback to them in real time so that while they're working, they can understand some of the issues and sort of get some correction along the way. And then there's all sorts of other, related issues, that we know relate to digital assessment, things like collusion and inclusivity and accessibility. So we are really involved right across the board in these areas. In terms of some of we have a couple of sets of resources which focus in particular areas. One of them is around lab techniques and how to support students really going into the lab feeling better prepared so that they can hit the ground running. So we have a whole set of resources that get students prepared, bite-sized chunks. So imagine, Linnea's resources that she showed just now, embedding some active learning resources alongside those. What I mean by active learning is that the things that we develop, students have to problem solve, they have to figure out what's going wrong, optimize an experiment, take an accurate measurement, analyze some data or think about how they might use the data afterwards. And because it's active learning, they have to get involved. They have to participate and engage in the content. And we'll show you some examples of how that works. I'm just gonna play this quick looped video so you get a sense of the kind of interactivity. So thinking about how equipment needs to be set up, students can pull together different pieces of equipment and then set it up and make mistakes and then get feedback and then recover from their mistakes. So make changes to optimize so that they can think about why is it important for us to work in this way and what will the impact of how I work in the lab have on the results that I collect and on the the analysis that I go through. So you can see there's a whole range of techniques and then some theory as well, because it's really important sometimes to link some of the theory to what they're doing in the lab experiment. So we've got, as well as a whole bunch of preparation and purification techniques, and we've got the instrumental techniques, things like mass spec and HPLC and NMR, to get students thinking about how those work. And then the other area that we work in really strongly is around data analysis and getting to helping students with how they can take that data, say from the lab, and understand how to run through complex calculations to prepare themselves, you know, to be able to analyze data. And we know that students struggle sometimes when they're pulling the data together to really understand what they're supposed to do with the data. And so what we've got here is smart worksheets. It's a different type of resource, but fundamentally what it does is provide immediate feedback to students as they're working through the data analysis. So you can imagine that they're typing their answers, they're thinking about how to maybe say running through a titration calculation or something like that. And as they're doing it, feedback pops up, which says, yeah, you're on the right lines, but you might need to change this, or you've got your unit conversion wrong, go back and have another go. And having this sort of real-time feedback coming through is really, really beneficial to the students. And I'm just going to jump out of this and play a quick video so you can see how that works. I just jump into our smart worksheet page. Just going to play this to give you a sense of what that looks like. There's no audio. So with these smart worksheets, the students can use their own data or model data. It's randomized, so each student gets something slightly different. And then they can work through these complex calculations. And every time they submit their answer, they get feedback or a hint to say, think about this or have another go. They can interact with their data. They can plot it on graphs. They can then start to run through their calculations. And you can see here there's feedback popping up along the way to help them understand what they're doing wrong all the way through. So all of the common errors that students make are all programmed into the back. So every time the student makes one of those common errors, it triggers focused feedback that the student can then apply and have another go at solving the problem. And there's lots of data analytics for this to help the student. And one really fantastic little feature is that they can preview, they can go back and play again all of the answers that they submitted and all the feedback that they got. So if they're revising further down the line, thinking about how they got on, they can go back and remind themselves of the errors that they used to make or that they commonly made, and remember that they need to not make those again. And of course, it's a really invaluable resource for academics as well, to go in and see the mistakes that students are making. In terms of other things we do, I mentioned that as well as the resources that we have, we really actively engage with the community. And I'd just like to encourage anyone who's listening to get involved and to participate. So we've got lots of special interest groups in really important areas around practical skills, mathematics, equality, inclusion, and effective and authentic feedback and assessment. So there's some really active learning and sort of academic groups coming together. The other area we get involved in is education research. There's lots of papers being published around the technologies that are being used and how different universities are using them in different ways. So, as I said, we provide a set of resources that is quite hard for universities to develop on their own, but when you embed them alongside those other resources which you're developing yourselves, you can create some really innovative student experiences and then generate some great research that's being carried out in those areas. And we also like to showcase great innovation, not only with the things that we develop, but with the kinds of things that all of you are developing. So we have Innovation Awards program. We'll be running our 3rd Innovation Awards this year, celebrating really great teaching STEM in digital innovation. And we have an independent, expert advisory panel that does all of the judging, an academic panel, an international panel that goes through and looks through a whole bunch of submissions that we get every year for really great academic innovation. And what we like to do then is to showcase all of that innovation on our website. So if you go onto our website, you'll see all of the submissions and, you know, presented on the website, because that's part of disseminating, you know, best practice. It's a big goal of ours to share and showcase really great things that are happening around the world. And finally, we also work in digital skills. So we have a digital champions program, and that is, you know, I'd really encourage anyone who's interested in getting involved in that. If you're interested in developing digital skills, then, you know, come and talk to us, because we've got a program which can help and support you with that, and also introduce you to other academics around the world who are also developing their digital sort of skills portfolio around all sorts of things like digital assessment, digital resources, digital feedback, you know, all of these areas. So I would encourage you to, yeah, to get involved with LearnSci, because we're much more than a digital publisher. We're very much actively engaged in the community. So I'm also, you know, a final area that we get involved in is thinking about some of your wider projects. So outreach, recruitment, teacher training, pre-sessional materials. We have our own LearnSci platform, which is supporting all sorts of initiatives out there. You know, outreach, working with, you know, high school teachers in the cities around universities, helping them to understand how they can start to use digital technologies around STEM in their courses and with their students, and hopefully inspiring students to then go on and study STEM subjects in universities. So I'm going to hand over to my colleague. Anthony, are you on?
Yeah, I'm right here.
Great. So if I stop sharing, do you want to show us some of the resources?
That sounds like a great plan. Let me just share my screen. Hello, everyone. I'm Anthony Spagnoli, of no relation to Dino, to my knowledge. I work at LearnSci. Thank you for taking your time to listen to us. There's been some great talks this morning. So I'm going to take you through one of our lab sims today. I'll just briefly show our lab sim library, the chemistry one, on the screen now. Just so you can see that we develop a range of resources that cover a wide variety of techniques and topics, whether that's from distillation to the full range of titration, from, you know, setup to endpoint, all the way into safety features and hazards in the lab. The resource I've chosen today is our Schenkline Fundamentals one, because I think it's one of the more exciting ones, and, you know, why not? So when a student loads up the resource, perhaps, you know, this is before they're going into a Schenkline lab, you know, you've set it as a pre-lab task. They'll be greeted with this screen. Now it's, you know, nice, bright and vibrant, and it lays out the yellows in front of them, so the student knows exactly what they're getting into. If I click this nice orange start button, go to the first page, we could see, you know, a model of a Schenkline. If I click this button here, a real life example as well. The students asked to hover over the labels and just build some familiarity with the equipment, because it is quite complex equipment. The student might not have faced it before, or if they have, you know, I'm sure that there might be steps they've forgotten. But the student can build this familiarity without actually having the equipment in front of them. If I go to the next page, the students asked to focus more in on a stopcock and actually orientate it so that the tap is open to the vacuum line. Now we have all these options here of you know, greasing, tubing, rotation, for the student to explore and make mistakes, or, you know, put the right ones in. So if I, you know, maybe I'll put flexi tubing in, and I'll rotate it, and I think this is on the wrong line, and it's going to tell the student, depending on what they put in, they're going to get tailored feedback. So because I've hooked up the tap to the nitrogen line, it's going to tell me I've done that. If I chose rigid tubing and put it to the vacuum line, it's going to tell me that, you know, rigid tubing doesn't allow for easy manipulation. If I put in all the right answers, it should pop up in the green and tell me, you know, well done, you've done this correctly. It might point out some important things, like, you know, it's important to mark one side of the tap to distinguish between gas and vacuum, for instance. If I go to the next slide, we're going to see about the oil bubbler, that, you know, The student's given the opportunity to adjust the settings to set up this specific component correctly and, more importantly, safely. So let's set it up not safely, and put the manifold to the top and close the outlet, and we'll see what happens if pressure builds up. It could result in quite a hazardous error. Luckily, the student can make this error in a virtual environment in complete safety while they're exploring these pieces of equipment. Perhaps I'll put the manifold to the bottom, and again, it's going to show you what can go wrong there. The feedback is going to be tailored to that. But if I put everything correct, it's going to show that we've done it correctly, and more importantly, it's going to provide some contextual info to help the student build that knowledge step by step, ready for them to be familiar with this equipment. For when they go into the lab, they can have that confidence to move forward. This next slide, it's all about setting the DOR to an appropriate height. So I'm going to just pop it there, and I do believe that's correct. And then we'll move on to the next one, where we're looking at the students being told to run cycles to degas the reaction flask, create an inner atmosphere, and they can adjust the turn rate. So if I set it to fast and turn the tap incredibly quickly, click check, we're going to see that not only have they not achieved an inner atmosphere, they've also adjusted the pressure way too quickly. If I put it to slow and run one cycle, for instance, we've got this nice visual representation of, whilst the molecules have moved, the atmosphere isn't inert yet, so we might need to run a few more cycles. And then the student would go through the motions of this and see that, not only do you have to be careful with your tap turn rate, but you also have to run a few cycles to actually make the atmosphere inert. If I click check, it's going to tell me that as well in the feedback. On this final step, the students, gone through and they've explored key pieces of this equipment, and now we're going to test their knowledge on each component and consolidate this learning, a real sound pedagogical approach. So the student's given a bunch of questions about each component that hopefully they should be able to answer correctly because they've just gone through the resource. If they can't answer it correctly, the resource is going to give them some feedback to point them in the right direction. And because I'm a slight completionist, I'm going to answer them all. But yeah, that was Schenkline fundamentals.
Thanks, Anthony. Do you want to just pull up the website and just show the full list of the chemistry resources so you can see? So, I'd just like to encourage you to contact us. We'll put our contact details into the chat. What we believe in is that we need to share this with you widely so that you can see the resources for yourself. So if anyone's interested in just exploring these resources yourself, we're more than happy to set you up with a login to everything that's there. Then you can have a play around, think about your course, think about how it might work. Anthony, I don't know if you had time to show us a quick smart worksheet.
I do, and in fact, I'll pull up one of my favorites. Do we have any pharmacologists in the room? Where are we? Now, I'm a biologist by trade, but I did have to study pharmacokinetics in my undergrad, and it was really a point of contention for me because it was incredibly difficult. But we find this resource makes things a bit simpler. So I'll give a bit of a whistle-stop tour because, I don't think we've got the time to go through the resource in such detail. The student will load up the smart worksheet and I'll be granted with this screen. Now, if I zoom out, I can use the actual accessibility features to zoom in. I could change it from light to dark mode. I could make it full screen if I wished. I'm going to keep it right here. I think that's visible for everyone. And I'll just go through each part in turn. So this sheet is designed to, go through an introduction to pharmacokinetics. And at the start, the student's informed they're going to be learning about key pharmacokinetic principles. So part 1 covers single dose pharmacokinetics. We start off with absorption and bioavailability. We get the relevant equations are listed, and we get to see a plasma concentration versus time graph. The students asked to answer some calculations related to the formulae shown above. And as you can see, these numbers, they look, slightly odd, if you might think, no round numbers. That's because all the data used is randomly generated, which means each student's going to get a different set of questions. This not only helps prevent collusion, but it means that you've got this authentic assessment that students can repeat and get a different set of questions and keep going through to build their knowledge and understanding. If I put in just a random answer so we can see about the feedback, the students given feedback depending on their answers. Now, obviously, I've got this wrong. The general feedback in this instance is to show out the equation involved and how a student might answer this question correctly. If the student was incredibly stuck, couldn't get further, they could click the solve button. They'll forfeit all their marks, but it will give them the correct answer. Now, this might help them with future answers or similar questions. So, for instance, with that answer there, I could round it up. And I might have a better chance at part 2 if I didn't quite understand it. If I go through, part 1b covers volume of distribution with a similar format and approach where it shows a graph, the relevant equations. In this case, like some of our other smart worksheets, the graph is readable. We can zoom in and look at different data points. Though because it's so linear and there's few points, it's not as useful in this instance. But the feature's there and it is seen throughout some of our smart worksheets. 1C introduces the impact of metabolism and excretion, again with more graphs and questions. For example, the student here is asked to identify, the correct terms and description to the graph. If I put in 0 order, a constant amount is removed. If I put in, an incorrect answer, it's gonna point the student in the right direction. And again, if I put in an incorrect answer, it's going to point the student in the right direction. With all the questions answered in some cases, and this one being one of them, you might get this nice green text pop up, which might provide some contextual info relevant to the correct answers. We've got further questions about elimination half-life, the elimination constant, and total clearance. And then if we go through and it finalizes in 1D, where we look at steady state, all of the numerical questions that I've scrolled through have been using randomized data thus far. Again, very useful tool in terms of actual repeat usage and preventing collusion with students. And if I continue through the sheet, we've reached part 2. This leads into multiple dose pharmacokinetics. It takes a similar pedagogical approach, introducing topics and then coming full circle and testing student understanding with questions, providing specific tailored feedback to their answers instantly, as soon as they put the answer in. I really like the graphs specifically in the sheet. They're good visual aids and they're quite engaging for the student. If we go down to part 3, we get some more practice questions to really hammer in, everything that has been learned and tested understanding thus far. Question 18 is very interesting because it provides this manipulative graph that students can explore the relationships between some of the terms they've learned, graphically. That if I change the x and y axes, that I can see how these different variables intertwine, and that I can use this graph to pull data to answer questions. Provided that I've set the axes and the scale in the right way. This builds not only student engagement, but allows them to explore these relationships, as I've just mentioned. And then as we get to the bottom of the sheet, you can see these nice analytics that the student could see, all the correct answers, how many points they've scored, how many they've also solved, how many they've not finished. Now, I'm a terrible student. I've missed nearly all of my questions. But you can really have your finger on the pulse to your class and your students, and you can know exactly how well they did in all of these smart worksheets, and how well, and the areas that students might have struggled, which you can focus your efforts on. Yeah, that was an introduction to pharmacokinetics.
Thanks, Anthony.
No
so
worries.
for a sheet like this, you can kind of see that within the whole sheet there are hundreds of pieces of feedback, specific feedback built in, which the students will will trigger depending on how they answer the question. So it's really, really sophisticated. And providing that real-time feedback is something that the students very, very much appreciate. And the other nice thing in terms of academics, we talked about saving academic time. These are all auto-graded assignments. So you could see the length and complexity of that assignment. When the student finishes, as the student finishes it, all of their grades are automatically graded and passed to the grade book. So you know, if you have a large class or even a small class, imagine the benefits of having an assignment like this and then having the grades auto-graded, and then being able to go in and spend your time maybe looking at the students who haven't done so well, or thinking about or investigating some of the areas where students have particularly struggled on, and then being able to focus on those rather than sort of the nuts and bolts of just going through each answer and grading it manually yourself. So hopefully, you know, it's a solution that saves you guys time as well as supporting the students. So we have a whole range of lab sims to support laboratory science, as well as a whole range of pre-existing worksheets which cover a wide variety of topics. So if you're interested in reviewing or seeing any of those, as I said, we're more than happy to provide you access with everything. Just get in touch, and we'll send you a login. And yeah, thanks for your time. And if you have any questions now, please go ahead.